This meeting is being recorded.
For problem 14, we are given two structures here, phenylalanine and cinnamic acid, and we are asked to predict the number of signals and the number of protons, so the number of signals and then the number of protons that give rise to each signal in a proton NMR spectra for both of these compounds. So our first compound is phenylalanine. We can note some symmetry within our benzene ring here. So that would give us a proton here, would give one signal. So this is our first, and one proton there. And then we have this proton here and here. These would give a second signal, so we're up to two. And then these protons here would give a third signal. So there's three signals just within our benzene ring. Then we note that we have these two protons here would give a distinct signal, so we're up to four. And then there's also a proton here that would give another distinct signal, so we're up to five. And we also have two protons here that would give us, these are non-equivalent diastereotopic protons here, so we would have a sixth and seventh signal here because of that. And then our last proton, this single proton here, would be an eighth signal. So again, we have 8 total signals. Most of them are single protons, except for the amine group, the NH2, and then the two sets here and here within the benzene ring. So we have 8 signals total. So let's take a look at this cinnamic acid next door here and see how many signals we can find. So we're going to, again, have that symmetry within the benzene ring. So we'll have one proton in our first signal here. Then we have here, we have 2 protons giving rise to a second signal. Then we have overlapped these. We have a third signal here. Again, 2 protons with our third signal. Then as we move a little closer here, we can see a proton above this pi bond and a proton below. So each of these single protons would give rise to a fourth and a fifth signal. One is a cis to the major portion of our compound. The other would be trans to the priority group. And then we have, again, our sixth signal here. So we saw a single proton for most of these, the diastereotopic protons 4 and 5. We see 2 protons in groups 2 and then in group 3 with our benzene ring. And then again, the remainder are all single protons. So 6 signals for our second compound.